everyone. My name is ABQARI, and so today I'm excited to present about my project on renewable energy automation. Specifically, I have built this, which I call a smart solar tracking system.
We all know that solar power is one of the most promising sources of clean energy. However, simply having a solar panel isn't enough. The efficiency of a solar panel depends entirely on how well it catches the sunlight. Today, I'm going to show you how I use Arduino technology to solve a major inefficiency in a solar power generation.
Here is the problem. As we already know, the sun moves. It rises from the east, travels across from the sky, and sets in the west. And the sun height also change depending on the season where we are live.
However, most traditional solar panels are static. This means they only hit their peak energy production for a short time, usually at noon when the sun is directly overhead. In the morning and late afternoon, the sunlight hits the panel at a steep angle, bouncing off rather than being absorbed. This results in a massive loss of potential energy. To get the most out of solar panel, it needs to behave like a sunflower, which actively follow the light.
So, my solution is this, our automatic solar panel tracking system. This is an electromechanical system that is designed to automatically detect the position of the sun and physically tilt the solar panel to face the sun directly. The system is powered by an Arduino Uno R3 board, which acts as the brain. It controls two SD90 servos, one for horizontal movement, which is left and right, and one for vertical movement, which is up and down. This machine actively hunts for the brightest light source in the room, or which is by the sky, ensuring the panel is always at a 90-degree angle to the light rays for maximum efficiency. So now, let me explain how it works. If you look at the top of the panel, you will see four photoresistive sensors, or we usually call it as light-dependent resistor, positioned at the four corners, which is top left, top right, down left, and down right. These sensors constantly measure light intensity. The Arduino reads these values and compares them using a specific logic code. For example, if the top left sensor detects more light than the top right sensor, the Arduino sends a signal to the horizontal servo to rotate the platform left until the light values balance out. If the top sensor reads higher values than the bottom sensor, the vertical servo tilts the panel upward. It does this continuously, making micro adjustments to stay locked onto the light. The system is also powered by an 18650 mobile power shield, which hold lithium batteries. What's really cool is that the energy generated by the solar panel feeds back into the system. It even has a USB output and a charge detector display that shows the current voltage and amperage being generated in real time.
Why go through the trouble of building this? Let's compare it to the static solar panel. A static solar panel might operate at 100% capacity for maybe 2 hours in a day. For the rest of the day, it might be operating at 40% or 60% capacity because of the angle of the sun. By using our tracking system, we extend the peak period, which is the 100% efficiency. We capture the morning sun and the evening sun with high intensity. While monocrystalline panels like this one usually have a conversion efficiency of about 24%, adding dual-axis tracking can significantly increase the total energy collected over a single day compared to a fixed amount. In conclusion, this project demonstrates how we can use just a simple robotics encoding, specifically the Arduino IDE and C++, to optimize renewable energy technology. While this is a small-scale prototype, the exact technology is used in massive solar farms to power cities. It solves the problem of the moving sun and ensures that we can harvest every bit of energy from the sun. Thank you for your time. I am happy to answer any question you have about the wiring, the code, or the build process. Thank you.